1.
Hi. I wonder if the dog people only want to baby back.
Okay.
I want you to sound as much as you can. And if you curl it like this, you can change.
Peanut butter, can I buy one?
It all depends on your teacher.
Yay!
Go grab one. You can borrow HPrecalc from the front. Then you have the cash box over here. You need change? Perfect. Need a quarter?
Oh, I'll stay in the door.
That's for you to keep for our wishes, deal.
Oh, okay.
Yeah, like you've done before. Do you have change?
Yeah, I do. Thank you. You guys some quarters. Let me check.
How about Joe?
Yeah, I got some.
yeah.
Thank you so much.
How about Joe?
Thank you.
Please.
How about Joe?
Okay, kiddos are taking their notes, trying to finish up. Well, we're going to finish up section 4.2. 3. Thank goodness.
4. What?
4.3.
Joe wants his mom.
Homework due tomorrow. So, we're going to talk about physics stuff. If I were you guys, I would grab out a calculator. I'm going to go get my calculator ready because we're going to be doing some plugging and chugging with word problems.
Oh, I read that one.
P.S. For trig, sine of, cosine of, tangent of, cosecant, secant, of. If you don't have one, as long as your group has one. As long as your group has one, we should be good. You can steal Emily's. She's still writing. You can borrow Emily's, I should say. Okay. Kiddos, what mode? Go ahead, hit the mode button, top row, second button over. What mode do we need to be wary of if we are doing sine, cosine, tangent?
Radians.
Ah, there you go. Is it degrees or is it radians? Now, for most practical physics problems, you're going to have degrees. In calculus, the entire year must remain in radians.
Oh.
Interesting.
That's
Mode.
not physics. We'll talk to it.
Most of you guys probably want to go to the third line down and go hit degrees. Because most of these will be in degrees. Yep. But in section 4.1, in section 4.1, did you guys have some arc length problems and some angular speed and linear speed problems?
Yes.
Some like application-y problems? Did I ever take or make any sort of note about your calculator in the mode?
Yes. Talked about it. It was like in a book.
I talked about the mode button?
No, the book did.
Oh, but in section 4.1, I didn't talk about it because we hadn't talked about trig functions yet. So when you were doing all those arc length formulas, it actually didn't make any difference because we weren't plugging the angles into sine or cosine or tangent. We were just plugging in, wait a minute, in those problems, in those physics problems, all the angles needed to be in what? In 4.1.
Radians.
All of them had to be in radians. So if you were given degrees, you had to convert. And in converting, you basically, in making them radians, made them dimensionless, which sounds really snazzy. Basically, you made them applicable to the formulas that you had, that whatever addition or subtraction or multiplication or division you were doing did not change based on whether they were radians or not. That's a problem though, because the number changed. You just need to have them in radians. But in doing so, in making them radians, the label didn't matter. Now, here's the really weird thing, guys. Hold on. I'm going to pause real fast because Laurel and Claire are the quietest I've ever heard when I wasn't talking. Okay. Let's try to keep doing that. So anyway, we have our calculator open, and in this section, though, we are going to be doing sines and cosines and tangents, which, help me out real fast. Ready? You guys are currently in degree mode, right? Mm-hmm. So go ahead and take sine of, let's do 10 degrees. Something tiny, something in the first quadrant. Sine of 10 degrees. It would not be 0. It would not be 1. It would be a little bit above 0. Does 0.17364 make sense?
Cease.
Something little, right? Sine up a little bit. 10 degrees, first quadrant. Okay. Now I want you to go to mode, change it to radian, and then type in the exact same thing. Negative 0.544. Huh? What's 10 radians?
10 radians is like all the way around.
All the way around, 6.28 and more. No, not 5 times. Careful, because 2 pi is 6.28. You're thinking 2, but 2 pi is 6.28. So you go 6.28. What's 6.28 plus 3.14? 9 something, right?
Oh.
So it's like in the third quadrant. Hey, it makes sense sine is negative, because sine would be going down in the third quadrant, right? And technically, couldn't we figure out exactly what degree this would be by converting? What's 10 times? How do I convert from radians to degrees? 180 over pi. So I'm going to multiply it by 180 over pi, and I can know exactly what degree that is. 572. We'll subtract 360, because whatever, it goes all the way around. 212. Yep, 180 and a little bit more. Okay. Do you see how you need to tell your calculator whether it's 10 degrees or 10 radians?
Yeah.
The answers will be very different if you're putting in degrees to trig or radians to trig, okay? So that's why we have to, I would go back to your mode and hit the degree mode. Yeah.
This one, the mode is degree, and we input a degree. What if you're inputting like a radian?
I'm going to change the mode. Or take your radian, convert it to degree, and we stay in the degree mode, but it'd probably be faster just to change to radians. So, all right, let's go ahead and talk about a few different right triangle problem clues. So, first of all, I'm saying, that's why I'm talking whenever I'm not talking. It's hard. Set up and label the triangle. So, do I want you to draw a picture? And the answer is yes. But I don't just want you to draw a picture, I also want you to label it. But what do we label pictures with?
Words.
Usually constants and variables, right? Yeah. Now, in calculus, the constants would be what isn't changing, what is staying constant. And the variables would be what's varying, what's changing. But for us, we actually don't get to really talk about movement too much. We more just get to talk about snapshots of time. Like, pause! Okay, what's going on? What constants can I fill in? And what variables, what unknowns do I have? So, until you get to calculus, where variables are actually varying, and there's movement and there's change, it's kind of more like variables are just unknowns, right? So we have unknowns and we have knowns, basically is what's going on in pre-calc, or anything before calc. And then we have to keep in mind all those properties that we talked about yesterday, and their rearrangements. Remember, it's not just the way it's written, it can be rearranged. Because sine squared of theta plus cosine squared of theta is 1. No. I was asking what sine squared of theta is. Plus cosine squared of theta is 1. No. What's sine squared of theta equal? Sine squared of theta plus cosine squared of theta is 1? No. What's sine squared of theta equal? Remember, we can take these properties and we can rearrange them. So we want to know them well enough that we don't just know them, but we also know their rearrangements. So what if I was saying what cosine squared of theta was? Do you see what I mean? Do you need to know this one? Yes. Do you need to know how to get this one and this one? Sadly, yes. Okay. So anyway, trig properties, not just the straightforward ones, not just the given ones, but also their rearrangements. Okay, a couple clues. Angle of elevation. Angle of elevation. If you're talking about, you'll be flying in a plane in a couple weeks. So, flying in a plane. So they talk about your elevation, right?
Yes.
What does that mean?
Like how high you are.
How high you are. Oh, from the ground, right?
From sea level.
Oh, easy. So, angle of elevation, can we just say from the ground, the angle that's going up? Okay, that's easy. Angle of depression. If someone is depressed, maybe you should go there, but go.
I was.
They're feeling
Down.
down.
The dumps.
So, you think, like, from the top of the mountain, looking down,
No, Gordon.
right? You're at the top of the mountain looking straight out. You're not at the ground, you're up in the sky, and if you want to look at the ground, you're going to have to look down.
You become depressed when you look down because then you're going to fall off.
Awkward. Or if you depress a button, doesn't that mean you're pushing it down?
No one said depress, just say press. Like,
Oh. Moving on. So, how basic could these problems be? Hey guys, is there like a paragraph describing to us this picture? Nope. Oh, so they're not all going to be word problems. Some of them are just right triangle problems. Hey, what's the title of section 4.3?
What?
Right triangle trigonometry. Oh, right triangle properties and right triangle Solving. Okay. So to get us ready for the word problems, to get us ready for the whole situations that we're trying to solve, let's just say we had a triangle, and let's say we were missing stuff, but we were given stuff. So remember, I know constants and variables, it's kind of confusing unless you're up in higher maths, but what do you know and what do you not know, right? I know 18. I know 60. It's a little confusing. I should have been a bit more precise. Sorry. Here you go. You know 60. What can you all assume this is? But careful with assuming. It'll be labeled. Okay. What do you know? 18 and 60 degrees. What do you want? X and Y. Can you solve for them two variables at the exact same time within the exact same equation?
No.
We have two unknowns. Don't we always need two equations?
Yeah.
So we have to set up two different equations. Just right now, we need X, we need Y. So you think about X and think about Y and say, okay, what do we know? 18 and 60. What do we want? X. Nope. What do we know? Hypotenuse and, I don't know adjacent, but if I'm trying to find X, I need to put together hypotenuse and angle and adjacent. Sha! Let's use secant. Ew. Well, use cosine instead. It's a lot easier.
I love cosine.
Secant is built on adjacent and hypotenuse, but so is cosine, and he's a bit easier. So cosine of 60 degrees is equal to adjacent over hypotenuse. So toa, right? So you think about what you're given, but you also think about what you want to find, and we had to think of them separately. So adjacent, hypotenuse, so cosine says, give me adjacent, give me hypotenuse with an angle. There we go. Now, if we were solving, we would multiply 18 to the other side, right, guys?
Yeah.
And then we would plug into our, no, we wouldn't. Oh. Would there be a
Cheater chart.
non-calculator portion of this test?
Use a cheater chart.
Why cheater chart? Isn't it 60 degrees, 30, 60, 90s, 45, 45? It's one of my special ones.
Yeah.
Struggle. Would you guys be able to say that this final answer is 9? Dun, 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 dun. Why?
It's 2.
1/2.
Wait.
1/2.
Wait a minute. So we need to be able to do some mental math?
Wait,
Hey.
where's the 60 go? 60, just, that's nothing.
No, it's where to look. Let me do Y and then I'll show you. Ready? Y. Who's that?
Opposite.
Okay, hold talking every time I notch. Y is opposite, right? So I'm not going to use cosine. I'm going to use sine. Because I had the 18, so why not just use the hypotenuse, and why not just use still opposite over hypotenuse? So sine of 60.
This one is triangles is
Exactly. Before we get to calculus, this triangle is like there is no movement of it changing shape, it's just this.
no, but like, you know how it's like the 3, 4, 5, and the 12, 13.
Oh, is this why it's set like that? Yeah. Because of the ratios of the trig. So what's this one going to be? 9 rad 3. What? KJ, Sophia, Alec. Hi. Why is it 9 rad 3?
Because 60 times 18.
No, because it's rad 3 over 2. Sine 60 is rad 3 over 2.
Okay, wait a minute. Where is Alec pulling this out of?
Cheater chart.
Cheater chart.
I like the cheater chart. Love my cheater chart.
Oh, yeah, I see.
You guys got a time? Yeah,
Wait,
I thought there were
so-
3 out of 2.
Okay. So you're just replacing the
When it tells me when it gets to 6, tell me go. Huh?
No, so
So you're just replacing the sine 60 with,
and I'm going to get a timer on her phone.
I should memorize it.
Just in 3, 2, 1.
But that's not.
Wait, why?
Nope, she started telling me.
That's all
Wait,
the
how
time
did she
is on.
start?
1, 2, 3, 3, 2, 1.
How many minutes?
Ah, 23 seconds.
And I started doing it.
60. Wait, these are radians. Oh, that's okay. Remember, 60 is 1/3 of 180. Remember, pi is 180? 60 is 1/3 of 180. This is the 60 column. This is the 45 column. This is the 30 column. This is the 0 column. This is the 90 column. So, and when we were looking at sine of my angles, right? Sine of 30 degrees or sine of pi over 3 was root 3 over 2. Sine of theta equals root 3 over 2. Sine of theta can be replaced with, all of sine of theta can be replaced with substitution. What is the ratio of sides? Who is sine? A ratio, a fraction, an opposite over a hypotenuse. So sine of 60 comes out as his ratio comes in. Because sine of theta is opposite. Which one? This one. How sweet. Cosine of 60 degrees, or cosine of pi over 3. Once again, he's a ratio, he's a fraction. He's an adjacent over hypotenuse, according to our cheater chart or the unit circle. Because pi over 3 is this guy, it's over a little, cosine's 1/2, it's up a lot. Sine is root 3 over 2. Over an Emily upper. Then we can go ahead and just plug in. So cosine of 60 gets replaced with his ratio 1/2. Dun, 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 dun.
Is that a 0 next to the sine of 0 on the cheater chart?
Yeah. There you go. I'm adding way more detail than I usually do. I usually just do these ones, but that's okay.
That's what it is.
So what if you guys have this guy? Oh, there's a paragraph now. I know, but doesn't it still just have a triangle? Oh my goodness, and they gave you the triangle? That's way nicer than they needed to be. A surveyor is standing 115 feet from the base of the Washington Monument, as shown in the figure below. You guys see the little baby man? These are trees. Baby man.
Baby.
He's not. He's a grown man. Just he looks baby in the picture. Okay. Staring at the Washington Monument, 115 feet from. I will say, ooh, do you guys see how the 115 feet from, is it to the edge of the monument or like the center? I'm thinking kind of center of gravity, although that would be up here somewhere. But anyway, we're thinking of the Washington Monument at one point, not this whole like, hey, it takes up space thing. So 115 feet from the middle. Okay. The surveyor measures the angle of elevation. You guys have seen people standing on street corners and whatnot, not surveyors, right? And they have their instrumentation, they have like long poles and they're trying to survey.
No, I feel like people with little notepads.
Oh, only the notepads? Those are the ones probably doing like surveys and how many people are running lights or how many people are doing this or that. Oh, yeah? With instruments, you can measure how far the angle is up to something. So this person has that sort of instrumentation. Now there is the whole awkward, like what if he's a certain height and so his instrument comes up here and then it measures from here. It's okay. We'll pretend that the instrument's on the ground and it's measuring perfectly. There are some things like that to make problems easier at this level. 78.3 degrees. How tall is the Washington Monument?
You stonks. So, the angle of elevation is 78.3.
Then you can use.
If this one's too confusing, can't you just draw like a basic one saying, okay, they're just talking about the Washington Monument as like a straight line. They're talking about the man as like a point. And they're measuring.
This one you can't, you have to use a calculator, right? Because it's not a,
Yeah, it's not a unit
not a
circle.
chart. And you just gotta do, just use use tangent, you gotta use tangent.
You have to use tangent. Why do
Because you don't have a
to use
hypotenuse.
tangent? See it? So we have an angle, check, so it can go inside a sine, a cosine, a tangent, a cosecant, a secant. We can put an angle inside because there are those buttons on our calculator, right?
So tan 78.3.
We need opposite, we have adjacent, the only TOA trig that'll really help is tangent. So with right triangle problems, you're thinking of your SOHCAHTOA and saying which one works with what I have and what I need. I had opposite. Well, I didn't have it, but I needed it. I had adjacent. I had theta. This guy is going to do what I need him to do. But as Alec already said, did you guys hear him say we have to use our calculator on this one? Yeah. because there is no unit circle equivalent of 78.3. So you actually have to go and do not sign. Sorry, handed. 78.3
There is a homework problem
times 150.
that was in our homework last year.
Say 555. I thought that was 0.31.
Our participant.
55.314.
That was a Sammy Hager reference.
Maybe it was a reference to science. Did I know it? What was the homework problem last night, Sophia? Or last year that you were talking
The
about?
one about the pollutants in the river. I remember talking about that.
There was a triangle problem?
Yeah.
Huh.
It was one of the word problems.
Interesting. Pollutants in a river. Here's a special relationship for you guys to keep in mind. We talked about complementary angles. Alec was talking about what HPrecalc is today because they just did complementary versus supplementary. We talked about complementary angles in 4.1. Complementary angles add up to be 90. So we could say something like it's a theta plus a phi that adds up to be a 90. Remember, Greek letters can be. So we should probably name him a different letter. Theta doesn't really make sense because that's theta. So if I was to rearrange this and I was to put this guy over here, that's a little awkward, but he should add up to be 90 degrees total. I guess I would technically put him this way. He would add up to be 90. But there is something about their trig ratios. Because if you guys notice, like, if this is theta, why am I able to label this as theta too? How does that have to be true from geometry?
Because it's next to BR. Or what?
Yeah, but the BR and the A, that all actually came as a result of this being able to be theta. So why was that able to be theta? And why does this have to be phi?
Oh, because it's 90?
Yeah, this is a 90 degree or a right triangle, which means 3 angles of a triangle add up to be? Ooh, geometry. Yeah, 180. 3 angles of a triangle add up to be 180. And if this one's 90, what do these two have to always be? 90 also. So if these two add up to be 90, if that's theta, this has to be phi. So if this is phi, that has to be theta. Oh, hey, so they're the same triangle, just kind of like flipped?
See.
Yes. So since this guy has ABR, this guy has to have ABR, where the shortest or smallest angle is across from the, shortest angle is across from the shortest side, wherever he falls, shortest angle across from the shortest side. Wait a minute, hold on, no. This wouldn't be A, what would it be? Why do I have to take away these labels and change them? What's wrong?
They're not proportional.
What does this guy have to be?
Bigger.
And this guy would have to be?
A.
So if I was actually having these represent the actual length of the sides, it would have to be switched, because across from theta is B, across from phi is A. Across from theta is B, across from phi is A. Which is why, right? If this was, that's way too skinny. Pi over 6. And if this was pi over 3. Wait, pi over 6, doesn't he have the over a lot and the up a little? Because he goes over a lot and up a little. Wait a minute, this is a pi over 6, that's a 30 degree. What would this guy be? 30, 90, he must be 60. Oh, that's pi over 3. Now we never put him because we're actually just looking here at that little angle in a unit circle. But this is really a pi over 6, pi over 3, pi over 2 angle, or a triangle, or a 30, 60, 90 triangle. So when I go up to pi over 3 instead, why is it that they just flip? Well, because now the pi over 6 is up here, the pi over 3 is down, so everything is just switched, like you see these two right here. So I can say something like the following relationship. I can say for 2 complementary angles, 2 angles that add up to be 90, like 30 and 60, theta and phi. I can say that cosine of theta is going to be the exact same, assuming they're in the same quadrant, so maybe I should do like no, adding up to be 90. They're both in the first quadrant. That's okay. Cosine of theta is going to be the same thing as sine of phi, which means sine of theta (90) minus theta. So if the cosine of this guy is going to be the same thing as the sine of that guy every time, because it's just going to flip, the triangle just kind of flips orientation, I can say then that cosine of theta equals sine of the complementary angle, whoever he is. We can make him a Greek letter, or we can just say, oh, or it's complementary, 90 minus whatever that theta is. And I can similarly say that sine of theta is equal to cosine of phi, which means cosine of 90 minus theta. And I can technically kind of keep going, except this gets a little awkward now, because tangent of this guy is square root of 3 over 3 for the 30 degree. 1 square root of 3. He's square root of 3. So it's actually going to be this reciprocal relationship, so it's not quite as pretty, so we don't really write it, but we could. We could say that tangent of theta is equal to 1 over tangent of phi, which is the same thing as, oh, wait, 1 over tangent. Isn't that cotangent? Maybe there is a formula for that. Remember, guys, if you are trying to do in your calculator sine, it's easy. Plug in the sine button. Cosine, it's easy. Plug in the cosine button. Tangent, it's easy. Plug in the cotangent button. But cotangent, how do you do that in your calculator? Or secant, 1 over cosine, or cosecant, 1 over sine. Remember, it's 1 divided by whatever the other trig is. Anyway, a couple special relationships of trig of angles and the corresponding trig of their complement. Have any of you guys ever realized that cosine is just sine with a co in front?
Yeah.
And cosecant is really just secant with a co in front? And cotangent is really just tangent with a co in front?
So
they're called co-functions because of this complementary relationship. Co-functions. Cosine is the co-function of sine. Cosecant is the co-function of secant. And cotangent is the co-function of tangent. It all comes back to this complementary relationship. I can keep going with cosecant and secant, but it's all right. Should know. Oh, that's it.
Just need 1 second.
So,
we got a quick homework help, and then our job today, if you guys were to look on our calendar, was actually to finish this section because it wasn't supposed to take long.
Oh, wow.
And start the next section.
Oh.
I know. It was in the calendar. It was last year, too. It's not just you guys. It's not punishment or anything like that. We just have to keep going. But I do have a homework help. But Priyanka, a question on this page?
For the tan equation, is it 16?
Oh, it's cotangent. COT.
Okay.
Okay. No, you're okay. It does kind of look like a 16. Sorry, cotangent. Thank you.
Wait, did Kyle BC also so much?
Their book's kind of crazy, though. You guys want to start playing with this homework problem / homework help? You're trying to make it match? Izzy, look at how big their book is. So their chapters are really small. I mean, they're full, but we're going fast. Whereas you guys have a lot more pages to get through. How do you, what is Study for the AP, but they cover chapters 1 through 8 first semester, and chapters 9, 10, 11 second semester. So they slow way down because 9, 10, and 11 are really hard chapters.
1 through 8.
But remember, they also did Calc AB last year, most of them, and so they covered like chapters 1 through 6 last year. Not of this book, of a different book, and so this one's covering it differently, but it's the same basic idea. So they're able to go fast. Nope, this is the other book.
Oh. Wait, which one is the first one? That one.
That's the second. Because that one covers it in kind of more of a high school way, and that one covers it kind of more in the college. Hey guys, we have to make I don't know.
Well, look, they're 55.
What looks easier, making this look like that, or making that look like this? Because remember
That look
yesterday,
like
there's
this.
givens and proofs, and we can't like blend them.
That look like this.
The instructions or to
That look like this?
Yeah.
Make what equal what, Sophia?
Instructions that make the left hand correct.
Okay, as we go into, this is actually just an introduction of a much bigger idea coming later. You guys thought that exponential logs were puzzles? Better puzzles are coming. But this is just an introduction. Sophia, eventually we're allowed to go left, right, or right, left. We just can't move one side to be on the other side. But Sophia just let us know the direction said to start on the left, so the sad thing is we have to make this look like that. Wait a minute, that's an addition and that's a multiplication. Any ideas?
Eliminate it.
How do we? Okay, we can. But don't we still just have an addition? How do we make addition multiplication? Oh, what if we did common denominators instead? So we would have to multiply, because common denominators put together, kind of. So, what would you multiply this guy by? Sine theta. Careful, not just sin, but sine theta over sine theta. And this guy by?
Cosine theta. Cosine theta.
Okay. So what do we get?
You get
Fractions, multiply across.
sine squared plus cosine squared. over
Good.
cosine
Now,
squared.
careful. Sine squared theta. There's a way of writing that, right? It is technically sine theta squared, but this is a nicer notation.
Over cosine sine.
One? Where did Emily get one? What sine squared plus cosine squared? Because I'm allowed to put them together because they
Tangent.
have a
Wait. That's a rhetorical reference.
Stop focus. Sine squared theta plus cosine squared theta is 1. Well, I don't get it. It's times. Okay, fine. It's times. Sine theta times cosine theta, but I want cosecant theta times secant theta.
Wait, how'd you get one?
Oh, it's from a Pythagorean property in that big old table
Oh, that's
Yeah.
2-1.
that says any sine squared plus any cosine squared as long as they're of the same thing.
Equals 1. Okay.
How can we break it up, Priyanka?
Wait, where are we? Are we up there or are we down here?
Math, we go one step at a time.
Oh, okay. So, the reciprocal property.
Oh, we could do that. So sine is equal to? And cosine is equal to? And what's 1 over 1 over? The reciprocal of the reciprocal. That might be helpful. Another way of doing it, like there are alternate methods. You could have also gone this direction instead. You could have said, hey, 1 over sine theta times 1 over cosine theta. Technically, fractions multiply across, so we can also pull them apart across as long as you keep the multiplication. And then reciprocal properties, the other ones, 1 over sine is cosecant and 1 over cosine is secant of theta. But either way, it should land in the exact same spot. Okay, that was just a homework help. But we are supposed to start the section. Oh, you guys might have a paragraph one. You got a picture. Just make a picture.
Caitlin.
Okay, here we go.
How many sections is it?
Oh, in chapter 4. Let me go.
8.
8? That sounds right. I was going to say 7.
Imagine how much chapter
We know the longest, right? The first one was 4.
Section 4.3. All right. Shh. Section 4.3 and 4.4 go kind of fast because they're both introduced in some ways in sections 4.1, 4.2. So section 4.3 was like SOHCAHTOA, it's a thing that we've already kind of talked about. And section 4.4, trig functions, sine, cosine, tangent, cosecant, secant, cotangent of any angle. Well, we've done lots of angles in the unit circle. Pi over 4, pi over 6, 7 pi over 6, 11 pi over 3. Yeah. Section 4.4 is actually just taking section 4.2 just a little bit further. So in some ways it's weird, but our book was like, unit circle, just the circle, section 4.2. Section 4.3, I guess triangles are actually applicable. I kind of did the triangles early. And section 4.4 says, okay, let's come back to the SOHCAHTOA HPrecalc and make sure you guys can do it of whatever we give you. Now, sometimes, like Alex said, sometimes it's like the only way to do the trig is to go to a calculator. That's 78.3. Yeah, no, that does not match up with anything in the unit circle. But this intro problem doesn't match up with anything in the unit circle either. There's no point on the unit circle that has a negative 3, 4. They have zeros, 1/2, or 2 over 2s, or 3 over 3 over 2s, and 1s. Positives or negatives, but there is no negative 3 and there is no 4. So how on earth can they be expecting us, giving us a point that's not on the unit circle, to find the trig? Draw a triangle. Draw a triangle. Sophia and Emily both had interesting ideas. Sophia said, draw a triangle. And my guess is, this is 3, 4, right? Oh. I can take that point. I can look at how far that point is from the origin, and I can say, I can make a triangle with that. But pause. Sine is built on opposite. Cosine is built on adjacent. Tangent is built on opposite over adjacent. When the triangle is drawn, what way? To the x-axis or to the y-axis? Because that way I can think that's my x and that's my y.
That makes sense. Okay.
Although Emily said, put it in your unit circle. Could we scale this guy back to be in my unit circle? Unit, it'd be up 1, over 1, down 1, back 1.
Sure.
But to scale him, wouldn't we have to know what his sides are to do that whole ratio thing?
Yeah.
Huh. So what do we know about the sides?
The sides is the hypotenuse is 4.
Huh?
No.
Wait, no. Oh wait, the x is negative 3 and the y is 4.
The x is negative 3. The y is
4.
positive 4.
And Pythagorean.
Pythagorean theorem, negative 3 squared plus 4 squared is 25, which means this guy has to be a 5, right? So I could technically divide everybody by 5, and as I'm dividing by 5, I'm shrinking my triangle to come back down and be a length of, instead of going out 5, to only go out 1. So that's one way. You could shrink it to be inside the unit circle. Or you could just say, wait a minute, before we ever learned the unit circle, didn't you guys learn SOHCAHTOA in like geometry? You don't always have to make the triangles fit in the unit circle. You could just look at the triangle and say, oh, hey, this is my angle, whatever he is. I don't know what he is. Something in the second quadrant. That's my theta. But look at this triangle and use it for SOHCAHTOA HPrecalc. What would sine be? So SOHCAHTOA opposite over hypotenuse, 4/5. Why is that a positive though?
Because they're both positive.
4 is up and then the hypotenuse is down. But what would cosine be?
Negative 3 over 5.
Negative 3 over 5. So since this triangle is not in my unit circle, I can't just steal x and steal y and say, yay, I'm done, because I have to actually, oh wait, my hypotenuse is no longer 1, it's a number. Okay. Opposite over hypotenuse, adjacent over hypotenuse, tangent would be? Yeah, it's 4 over negative 3, but a positive over a negative is just a negative of the entire value. So negative 4/3 or negative 1.3333.
I have a question.
Yeah.
Why'd you draw the 3 over 4 on the other side?
Oh, because I was starting to graph it and I was like, oh, it's a negative 3. Sorry, just kidding. It was a just kidding. So where else is this function, this section gonna go? It's gonna say that sometimes we're gonna have angles that land in the second quadrant, or that land in the third quadrant, or that land in the fourth quadrant. Do you guys realize that when you're doing Sophie to HPrecalc, you're looking at, or you should still look at, can still look at triangles, but the angle is no longer always in the triangle. Sometimes it's outside. So theta would be out here, but to find theta, I want to look at my adjacent, opposite hypotenuse for a reference angle that we can kind of say like, hey, this guy's triangle is the guy to use for this theta. Or this guy's triangle is the guy to use for the bigger theta with the opposite and the adjacent and the hypotenuse. Or this guy's triangle is the guy to use. So if we can use triangles, sweet. We just need to realize that if our angles land in weird places, which triangle to use. Alright guys, we introduced 4-4. Good job. Tonight finish 4-3. Come tomorrow with questions, we'll grade it tomorrow. None of this like fall behind our Bye Claire, bye Laurel.
Miss Amy, Cassie are coming tomorrow.
We're